Okay, so the famous detour proof. A detour proof is, kind of exactly what it sounds. Um, so it's a proof where we might be asked to prove triangles congruent, or we might be asked to prove something about, something beyond the triangles being congruent, but we can't get to the exact proof statement directly from the given information. So we kind of have to go a roundabout way or a detour way in order to get there. So let's take a look at an example so that you can kind of see what I'm talking about. So our givens here are Sn is congruent to Un, and Gn is congruent to Fn. But we're being asked to prove that triangle USG, which is this one here, USG, is congruent to SUF. Those are those overlapping triangles there. But based on the information we have, we don't have enough information to prove those overlapping triangles congruent, right? Because we don't have, we could get one of the sides, and we could get this, that shared side, that reflexive side, but we've got nothing else. We don't have an angle in those particular overlapping triangles. We don't have any information that can lead us to conclude that those two triangles are congruent yet. But what we can do, is pretty clear here, is we can prove these triangles congruent, right? So if we prove SNG and UNF congruent, then maybe we can use something from that to get us, to USG and SUF. Okay, so I think I'm going to write just mostly the statements and not all the reasons, just to save some time here. All right. So first we're going to prove SNG and UNF are congruent. And we could do that pretty much with the given statements and with the vertical angles. So SNG is congruent to UNF. Those are the angles. So that we have an angle, we have a side, and then we have a second side. So by SAS, triangles SNG and UNF are congruent. All right, so now that we know that those triangles are congruent, take a look at some information that we can have from there. So take a look. We're looking for these triangles, right? We're looking for those triangles, but we already have these two triangles. So that means we could use CPCTC to get pretty much everything we need to prove that the overlapping triangles congruent. Okay, so we're going to kind of start like almost a second proof here. Okay. So step 5, after we've proven that one set of triangles congruent, we're going to go to CPCTC to get us, we're going to get these sides here, SG and UF. So SG and UF are congruent by CPCTC. And actually, we can do these overlapping triangles in two different ways. We could do another CPCTC and get angle G and angle F, and then use addition to get, so we can get angle G and angle F by CPCTC, and then we could use addition to get this side and this side, or we could use addition to get this side, and then use the reflexive side. So we can either prove these overlapping triangles congruent by SAS, using two CPCTCs, or we could prove them congruent by SSS, using addition and the reflexive property. So that's a personal preference. I think I'm gonna do SAS. So my step 6 here will be angle G is congruent to angle F. That is also CPCTC. So that's another S. That's another A. Step 7, I'm going to go with GU is congruent to FS. And that's by addition. Okay, now notice I don't need to restate those sides being congruent because I already did it up here in steps 1 and step 3, right? So I can kind of indicate that here maybe if I want to. Okay, but steps 1 and 3 basically I added together to get those sides. And move down a little bit here. Step 8 is that triangle USG is congruent to triangle SUF, and that is by side angle side is how I chose to do it. But again, you could have easily chosen to do it by side, side, side using the reflexive. So we'll start to see with the detour proofs, there are going to be so many ways to do it, so while I did it in 8 steps, some people might do it in 10, some people might do it, I don't think you could do it in less than 8 steps, this particular one. But depending on what detour you choose and how you choose to get there, there are a variety of different ways to do the detours. So let's look at one more, and then next time we meet in class, we'll have plenty of opportunity to work on these. Okay. So now let's take a look at what we have. We have BD bisecting ABC. So these two angles here are going to be congruent. And we also know 3 is congruent to 4. We're being asked to prove AD and CD. I'm not going to mark those congruent yet. Okay. I just want to take a look at the information I have. Okay, so AD and CD are in these triangles here, these little ones, AED and CED, or they're also in the big triangle here, ABD and CBD. Okay, so if there's a way we can prove either those two small triangles congruent or these big triangles congruent, then we can get CPCTC for AD and CD. But based on the given information we have, I don't think we can get either of those two sets of triangles congruent, but it does look like we can get, ABE and CBE congruent. Hopefully you can see that pretty clearly by ASA, because we're given the two angles, well, almost given the two angles, and then we have the reflexive side. So we can get these two triangles congruent, and then we could use some CPCTC magic. We could use congruent supplements or subtraction, whichever you like, to get these two bottom congruent. That would be one option. Another option, we could get these big triangles congruent. Again, CPCTC over here will get us there. And then we would have side, angle, reflexive side for the big triangles. That's actually a shorter way because we don't have to deal with the subtraction or the congruent supplements here. But again, multiple ways to do these detours. So it's always good to kind of plan out your procedure, what you're going to do, either in your head or write some notes down, and then kind of just decide which is the most efficient way, but again, there's so many different ways to do these detours, so as long as your logic makes sense, then you're okay. So let's take a look at this. So as we said, we're going to prove AEB and CEB congruent first in order to get to what we need. So BD bisects ABC. Again, I'm going to not write all the reasons just to save some time here and make this video not be too ridiculously long. Because BD bisects ABC, we can say that angle ABE is congruent to angle CBE, and that's by bisection. All right, so that's one of our angles. BE, I'm going to go with side. I'm just going to do it in the order that I'm proving, right? ASA. So BE congruent to itself. That's a reflexive property. That's our side. And then angle 3 and angle 4 are given. Those are congruent. And our triangles are congruent. ABE, CBE. And that's by ASA. So now we have those two smaller triangles congruent. We can now use CPCTC, right, to get these big ones we're looking at now, these big triangles congruent, right? And it looks like we're going to have to do it by SAS. We already have the two angles from the bisection. We have that longest side now, or that longer side, that longer reflexive side. We have AB and CB by CPCTC, and those two triangles will get us what we are trying to prove. So 6 AB congruent to CB by CPCTC. We already have the angle from before, so I'm just going to put, so this was a side here on step 6. I'm just going to put another little A here in red next to the angle ABE congruent to angle CBE because I'm reusing it for the new set of triangles. So again, you do not need to restate it if you have it there. It's unnecessary to restate it. I do need to state the reflexive side because this side is different in the bigger triangles than it was in the original. So this is a reflexive. And this up a little bit here. Oops. Step 8 is that triangle ABD. It's congruent to triangle CBD. And that is now by SAS. And if you want to just remind yourself, SAS, the first S was step 6. The A is from step 2. The second S is from step 7. Okay, so sometimes with the detours it's good, especially with that second triangle, to remind yourself where all that information came from. So we have those two triangles congruent, and that's all we need to get to our final statement because we were just trying to prove that AD was congruent to CD, and we can now do that by CPCTC of our second set of triangles. So the next time we meet in class, we'll get some practice doing these detour proofs, and some of them will be a little bit longer. Just kind of depends on what the information that's given and kind of what route you choose to prove the triangle's congruent. So we'll have plenty of time to practice that the next time we meet in class, and really for the next couple of class periods. Let me know if you have any questions.